In this video, we're going to take a look at a method of integration known as integration by parts. You will find this method very useful when you're trying to find the integral of a product. So again, if you have a product of two functions, and particularly if one of them is a transcendental function, like the exponential function, the logarithmic function, a trigonometric function, that's when this method will come in most handy. And so you can see I've written the rule for us here, and it really doesn't make any sense until we actually do practice together, so that's what we're going to do. The hardest part really, and it's just practice, 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 is choosing which portion to be dv, which function is going to be dv, and which function is going to be u. And so some general guidelines are, if dv is the most complicated portion of the integrand and it fits a basic integration rule, then that makes it easier for us because it's already simple to turn back into v by integration. Or, of course, if you let u be the portion of the integrand whose derivative is simpler than the original equation, because obviously we're going to find du as part of our function. So we're going to end up with all of the parts, so u and du, v and dv, but we get to kind of pick and choose which is which in the original equation. So let's take a look. Let's take a look at our first example. This is asking us to evaluate the integral of x times sine of x dx. So the first thing you should notice is this is a prime example for using integration by parts, because I have a function here of x, and I have a function here of sine of x. And so I have the product of two functions, and the second function, the sine of x function, is a transcendental function because it's a trigonometric function. So this is exactly the type of question where you would use integration by parts. So let's take a look, since this is our first example, of how to make that choice between which one's u and which one's dv. So just as a reminder, in case you don't have it memorized yet, the integral of u dv is equal to uv minus the integral of v du. And so what we're looking for is we're trying to make this guy a simpler integral than this guy, right? And so let's take a look at our options. We have u and we have du, which is just obviously the derivative of u. And then we have v and we have dv. Now u and dv are the two that I'm going to choose, and the others I'm going to calculate based on my choice. So I'm going to sort of look at this in two parts or two ways. So I'm going to start with setting u to be x, and therefore dv, because those are the two we choose, has to be sine of x dx. Sine x dx. Now, if I choose that, then let's think about the result. If dv is sine of x dx, then v, by integration, is negative cosine of x. And if u is x, then the derivative of u is the derivative of x, which is just 1 dx. So I'm liking this one, but let's take a look at what happens if I used a different option. Remember, the other option was to set u to be equal to sine of x and dv to be equal to x. Now, if I choose this method, then I would have to integrate integrate dv, which is x, to find v, which would give me x squared over 2. And I apologize, I forgot the dx here. And then I would have to find the derivative of u, which is sine of x, to find du, which would be cosine of x. Now, between the two, let's think about what would happen here. this part is the part that you really need to pay attention to. To find the integral of v du, I can either be finding the integral of cosine of x dx, or the integral of x squared over 2 cosine of x. And again, I apologize, I forgot the dx. Now, which one would I rather do? Well, if I think about, I'm going to box that a little bit better. If I think about the one on the right, the one in purple, this is going to be the integral of two functions that is a product, and one of them is transcendental. So what's going to end up here is I'm going to have to do integration by parts again. So don't choose that way, because we're trying to make this easier on ourselves. So we're going to choose this first guy. So that means the integral of u dv is just going to be u is x, dv is sine of x dx. I'm going to take u times v, so that's x times negative cosine of x. And I'm going to subtract the integral of v, which is negative cosine of x. So I'll just go ahead and write it as it is, just for now. Negative cosine of x, and then du, which is 1 dx, or just dx. Now, of course, I'm going to go ahead and move this negative to the outside, which would make this a plus, and get rid of the negative on the inside. So from here, it's just doing the math, and this is pretty easy math. I'm going to simplify my first expression to just negative x cosine of x, just by popping that negative to the outside. And then, of course, to integrate cosine of x dx, I get sine of x, and then plus c. And that's all I had to do. So again, just keep in mind that you can make it easy on yourself, as we did, or you can make it difficult on yourself, and I don't suggest doing that. Let's take a look at another example. If I want to evaluate the indefinite integral of 5x divided by e to the 2x dx, and you might be saying, hold up, you said this was for products and this is not a product. But of course, we know that we can rewrite this as 5x times e to the negative 2x dx. So problem solved. Now we have the product of two functions, and one of the functions is a transcendental function, because it's that e to the negative 2x, the exponential function. So again, we're going to just copy our formula down so that we know where we're headed. We're taking the integral of u dv to be uv minus the integral of v du. And again, I have some choices to make. I've got u du v dv, and I'm choosing dv and I'm choosing u, and I'm keeping in mind that this I want to be as simple as possible. So when at all possible, we want du to not be a function, because we only want to have to integrate with one function. We want it to just be a constant, or dx. So keeping that in mind, again, let's take a look at my two choices. My two choices are 5x and e to the negative 2x. So which of those would give me a constant for the derivative? Well, obviously that would be 5x. So I'm going to choose 5x here, which would mean the derivative of 5x is just 5 dx. And again, I'm doing that because I want this guy to be as simple as possible. And just having this constant in here makes it easy, which means I only have to deal with v. So let's see what v is going to be. If 5x was u, then dv is e to the negative 2x dx. So now I have to integrate. Remember, to get from here to here, I'm just going to take the integral of e to the negative 2x dx, and that would give me negative 1/2 e to the negative 2x. So from here, now it's just a matter of plugging things in properly. So the integral of u, which is 5x, dv, which is e to the negative 2x dx, is equal to u times v, so 5x times negative 1/2 e to the negative 2x, minus the integral of v, which is negative 1/2 e to the negative 2x, du, which is 5 dx. So of course what I'm going to do is do some simplification because I've got some madness going on. The left-hand side, 5x times negative 1/2 e to the negative 2x, can be simplified fairly easily. Negative 5/2, don't forget your x, negative 5/2 x e to the negative 2x. And then before I integrate, I'm going to simplify by taking the minus on the outside, the negative 1/2, and the 5, and just smushing it all together on the outside. So negative 1/2 is positive 1/2 times 5, so that's positive 5/2, and then I'm going to integrate e to the negative 2x dx because that's what was left over. Now, we already know what the result is when we integrate e to the negative 2x dx because I did it up here, and so that's what I'm going to get again. Negative 5/2 x e to the negative 2x plus 5/2, which is on the outside, and then this again, negative 1/2 e to the negative 2x plus c, and then the only thing I have to do is simplify a little bit. So I'm going to take 5/2 times negative 1/2, which gives me negative 5/4, and really everything else is going to remain just as it was. Let's take a look at another example now. We want to evaluate the indefinite integral of x to the 5th times the natural log of 3x dx. Again, keep in mind where we're headed. So the integral of u dv is equal to u times v minus the integral of v du. And I'm choosing a u, solving for du, solving for v, and choosing a dv. And again, my two choices are x to the 5th and the natural log of 3x. So again, the choice is yours, but keeping in mind, if I choose dv to be the natural log of 3x, then I have to integrate the natural log of 3x. And we haven't learned how to integrate with natural log. So we know how to do the derivatives though, so that's what you should do, is take the natural log of 3x and make this x to the 5th. Again, just to make things as easy as possible on you. Now, the derivative of the natural log of 3x is 1 over 3x times, using the chain rule, 3, which gives me 3 over 3x, or 1 over x. V is the integral of x to the 5th, which is a simple general power rule, so it's x to the 6th over 6th. And of course, I always forget dx and dx. So now that I have everything set, let's plug them in. So my solution for the integral of u, which is the natural log of 3x, dv, which is x to the 5th dx, is equal to u times v, so the natural log of 3x times v, which is x to the 6th over 6, minus the integral of x to the 6th over 6 times 1 over x dx, v du. So again, doing any simplification I can. This guy is just x to the 6th over 6 natural log of 3x is generally the order that you're going to write that in. Here I'm just going to do some simplification. I'm going to take my 1/6 to the outside, and then I've got x to the 6th divided by x, so just x to the 5th dx. And obviously that's going to be pretty straightforward. So x to the 6th over 6 natural log of 3x minus 1/6. What am I going to get here? Again, using the power rule, I'm going to get x to the 6th over 6 and then plus c. So my result is x to the 6th over 6 natural log of 3x. And of course, if it bothers you to write it that way, you can write 1/6 x to the 6th. It's really the same thing. And then here I've got minus, I've got negative 1/6 times x to the 6th over 6. So again, if you prefer to write the fractions separately, 6 times 6 is 36, and then x to the 6th, and then plus c. Let's do just one more practice together. I felt I needed to do a practice question where you actually had to integrate by parts twice. So yay for us, we're going to do that next. So as always, I'm just going to recopy this because it's always good to have our goal in mind. And again, I've got an x squared and a cosine of x, so I have two functions. I'm going to do u du v dv. And again, I can choose whichever one I want for whichever one. I'm going to choose u to be 2x because, again, the derivative, I'm sorry, x squared. I got ahead of myself. This is going to be x squared because the derivative is very easy to find, which is, of course, 2x dx. So now that leaves cosine of x for dv. So now to find v, obviously I need to integrate the cosine of x to find sine of x. So as I'm working through this, the integral of x squared cosine of x dx is u times v, so x squared times sine of x. I'm not even going to put the parentheses because it's perfect, just like that. Rarely happens. Then I get the integral of v du. So I get the integral of sine of x times 2x dx. So again, this is why this one's a little bit harder, because as I can see, what I'm left with here, because my derivative had an x in it, it made it much more difficult, because now I have the product of two functions and one of them is transcendental, so that means integration by parts. So I'm going to go ahead and redo this. So u du v dv. So just as I did before. So it's not super difficult, it's just more work, really. Again, I have to choose sine x and 2x. I have to assign those to either u or dv, just as I did here, where I took the one that would have the simplest derivative and made it u. I'm going to do that again. So this is going to be 2x, and this is going to be sine of x dx. And so the derivative of u is just 2 dx. And the antiderivative of sine of x dx is negative cosine of x. So my solution is, again, all of this stuff that I had before. So don't forget that you had this as part of your solution. And then I'm subtracting everything that I get from this integration by parts. So I'm just going to write nice big parentheses there to remind me that everything is being subtracted. And so again, I'm just going to use that formula. So u times v, 2x times negative cosine of x, minus the integral of v negative cosine of x, so I'm just going to make it plus and positive cosine of x. And then du, which is 2 dx. So I'm going to put the 2 on the outside. So now, again, x squared times sine of x minus, and this is actually going to be a plus because I've got a minus right here. So this is going to be plus 2x times the cosine of x. And then I'm integrating again here. I'm integrating cosine of x. And cosine of x is going to give me sine of x. So this is the minus 2 sine of x plus c. So I've got x squared sine x plus 2x cosine of x minus 2 sine of x plus c as my final solution. Again, not horrible, just that we had to do integration by parts twice because we ended up with an integral that required us to use integration by parts again. Up next, we're going to take a look at section 8.3, which begins with integrals involving powers of sine and cosine.